Assalamu alaikum. Hope you are fine and doing well. Today we are going to learn or study our experiment number 2. But before starting our experiment number 2, I am just reminding you one thing, that try to take this lecture on your laptop instead of your mobile phones, so that you can learn that what is going on. If you are taking a lecture on your mobile phone, then it is very difficult for you to understand the concepts that I am trying to deliver you. So it is again requested to take lecture on your laptops, not on your mobile phones, and try to write down the key points that I am telling you on your notebook as well. So I have started recording the lecture so that some students who are unable to join our online class can learn or can listen to this lecture at any time, at a later time. So let's start our experiment number 2. Can you see the shared screen?
Yes, sir.
Okay. The title of our experiment number 2 is Verification of Inverse Square and Lambert Cosine Law. This experiment is related to the utilization of energy part. I have told you earlier that in this course of lab of power distribution and utilization, we have two main parts of this course. First is the distribution part, power distribution, in which we have to study the distribution system, and the second part is related to the effective utilization of electrical energy. So that particular experiment is related to our CLO number 2, that is related to the effective utilization of electrical energy. There are a total number of experiments that are related to illumination or light schemes. So that experiment is one of them. And this experiment contains the practical performance, but this experiment is very simple and can be performed in your homes. So I have chosen this experiment in lab number 2 so that you can perform this experiment easily without going to the laboratory. Objective. The basic objective of this lab is first to study about some illumination measurement and what are the terms that are used in illumination or in light topics. And then we have to study the laws, and then we have to verify them. In this lab, we have to study two basic laws of illumination. The first is verification of inverse square law, and then we have to verify the Lambert cosine law. So that is basically the objective, to study about the basic schemes or basic terms related to the illumination, then how to measure it, then study different or basic laws of illumination, and then verify them. Any question till now? That what is the purpose of this lab, what we are going to learn after the completion of this lab. Objectives basically tells us this, that what we are going to study, what is the benefit or benefit of this experiments, and what would we learn after completing this experiment. That's basically described by the objective of this lab. So any question here? Let's move further. Apparatus. The apparatus required to perform this particular lab is, first you have to require a meter rod or a measuring tape just to measure the distance between 2 points. So I assume that meter rod or a measuring tape, or you can say that inch tape that measures the distance in inches or in centimeter or in meter, is available in almost all the houses, and it is available in your homes. And for example, if measuring tape or inchy tape is not available, then you can measure if the distance between 2 points with the help of a scale or a ruler, etc. You can measure the length of a scale of a thread with the help of a scale, and then use that particular thread to measure the distance between 2 points, and that distance would not be greater than 2.5 meters, or 2 meters. So you can easily measure the distance between 2 points with the help of a scale or a ruler as well. And if measuring tape or meter rod is available, then it is better for you. The next is the light source or a bulb. In this experiment, you would be required any bulb or a light or an energy saver, or any light source. And I think that is also available in your homes. And that light source should be a pointed light source, like bulb or energy saver, not a tube light, etc. Because tube light is not a point source, and that would not be required for the performance of this particular experiment. Third one is Lux Meter. Lux Meter is a device or an instrument used to measure the light, or you can say measure the intensity of light in lumens or in lux. That particular meter is not available in your homes, but your smartphones can measure the light, or can be converted into a lux meter by just installing a single app. That would I tell you. There are several applications available on Play Stores with the name of a light meter or a lux meter. By just installing the app on your mobile phones can be turned into a practical lux meter that measure the intensity of light that would be required in this experiment, and that you have to measure the intensity of light in lumens or in lux. So any smartphone can be converted into a lux meter by just installing a single app. That app is readily available on Google Play Store or Apple App Store easily by the name of light meter or a lux meter. And that is just a single application that I am telling you, that it is with the name of light meter. It is available on App Store, and it measures the intensity of light in lux. So you can easily install this app and convert your smartphone into a lux meter, and easily perform this experiment on your homes. The fourth thing is required is angle measuring instrument. Any instrument, with the help of that instrument, you have to measure the angle. This can be the angle can be measured with the help of any protector or a D. You can say that in short words. Or there are some applications that are also available to measure the angle on your mobile phones as well. So you can measure the angle with the help of a protector or a D or any angle measuring instrument, or you can install any app on your smartphone to measure the angle. So these are the apparatus or instruments that are required to perform this particular lab, and this lab can easily be performed in your homes. Any question here? So let's move further. Theoretical background, theory or theoretical background, in which we would study about these basic laws, that what these laws states or tells us. First is we have to define the term, that is illuminance. Illuminance is, but before learning about the illuminance, first we have to study about the luminous flux. Luminous flux is actually the perceived power of light. It means the light that we are receiving on any surface that we are working on is called luminous flux. Basically, there are two types of flux. One is radiant flux and other is luminous flux. Radiant flux tells us the total amount of light that is radiating from a light source. It means emitting from the light source. And other is luminous flux. Luminous flux is the perceived or the received amount of light that we are getting on any surface. So you understand what is the basic difference between radiant flux and luminous flux. Radiant flux is emitting amount of power, and luminous flux is the perceived or receiving amount of power that we are receiving from any light source on any surface. That is called the luminous flux. Now we would come back to our illuminance. What is illuminance? Illuminance is the total luminous flux, means perceived amount of power of light that is incident on a surface per unit area. It means that the total luminous flux that we are receiving or on a surface per unit area is called illuminance. It actually measures that how much incident light illuminates the surface or light the surface. Clear or not? Any question here till now?
Clear, sir.
Okay, let's move further. Now that is our first law, inverse square law. That is the title of the law. That's first we have to study the inverse square law. Then we have to verify that particular law. Then we have to study the Lambert cosine law and then verify that particular law. So here comes our first law, inverse square law. This law states that illuminance, just ignore the text that I have highlighted in blue light. Illuminance is inversely proportional to the square of distance between the source and the plane. Source means the light source. It can be a bulb or a lamp or energy saver or any light source. And the plane means the surface that we are working on. That surface can be a table, can be a floor, can be a chair, or can be anything. So again, study that. This law states that illuminance is inversely proportional to the square of distance between the source and the plane. But there is a condition associated with it. That condition is we have to measure the illuminance at any point on the plane perpendicular to the line joining the point and the source. That is the condition. First, illuminance is inversely proportional to the square of distance between source and the plane, but that can be measured with the plane perpendicular to the line joining the point and the source. It means that the angle of incident ray and perpendicular to the source must be having zero angle. Must be in line. You can say that you don't have to tilt the surface. You have to keep the surface perpendicular to the line joining the point and the source. It means you have to keep your surface perpendicular to the incident ray. The light ray should be incident at the surface perpendicular to the plane. Now again, we would study that particular definition. This law states that illuminance at any point on the plane perpendicular to the line joining the point and the source is inversely proportional to the square of the distance between the source and the plane. And the mathematical representation of that particular law is E. Illuminance is equal to I over d square, intensity of light divided by d square means distance, square of distance, and I is the luminous intensity in any given direction. This law can be clear with the help of this particular figure. Suppose that is the light source here. At any point, that can be a bulb or a light or a energy saver or a light that is emitting light in all directions. We have to measure the light at a particular surface. Suppose that is our surface on which we are going to measure the illuminance. So at a distance d or 1 meter, we have a particular amount of illuminance that we are receiving on this surface. But if we increase the distance to 2d, or you can say that 2 meter, then the surface area on which that particular light is perceiving is 4 times to that of unit area, and the light would be same. That is passing through that particular unit area. Now the unit area is increased to 4 times. It means that the light we are receiving at per unit area at the distance of 2d is 1/4 times of the light that is incident on this surface area. And similarly, if we increase the distance to 3d or 3 meter, it means that we are perceiving or receiving the light at per unit area is 1/9 times of the light that we are receiving on that particular surface area. That is the law states that illuminance, that it means that that the light we are receiving is inversely proportional to the distance between the light source and the plane that we are working on. These are three planes. The first plane is at 1D or 1 meter. The second plane is at 2 meter or a 2D. And the third plane is at 3 meter distance, or you can say that at 3D distance. And Illuminous law states that it is inversely proportional to the square of the distance between the source, light source, and the plane that we are working on. And that law states that that is luminescence per unit area. So area is increased, but the light is same. The same light is passing through that particular unit area, and the same light is passing through that area. But the light that is passing per unit area is 4 times less than the light that is passing from that particular surface area. Clear or not? Any doubt here?
Clear, sir.
Basically, in short terms, in short lines, we can say that illuminance is inversely proportional to the distance between the light source and the working plane. That is the basic or theme of this particular law. That is the first law, inverse square law, that the relationship between illuminance and the distance is inversely proportional. Now the second is the cosine law of illuminance, that is also called as Lambert cosine law. The cosine law of illuminance. This law states that illuminance at a point on a plane is proportional to the cosine of angle of light incident. It means that the incident ray or incident line that is incident on any surface is making an angle with the perpendicular of the plane, and that illuminance that we have studied earlier, illuminance, is directly proportional to the cosine of that particular angle, the angle that is making between the incident ray and the normal to the plane. So our formula of illuminance would becomes that E is equal to I divided by D square multiplied by cosine of theta, where I is the intensity of illuminous intensity, D is the distance between the light source and the working plane, and cos is the trigonometric function, theta is the angle between the incident ray and normal to the plane. That is the theta. Theta is the angle between the incident light or incident ray and normal to the plane. That is the final equation, and both laws are combined in this particular formula as well. And this can be cleared with the help of this figure. Now, this black line is the surface on which we are going to measure the illuminance. And first here, if we have a bulb installed at this point, then the normal to the plane would be perpendicular to that particular line. That is the plane, and normal to the plane would be 90 degree to that particular plane. And when the bulb is installed at 0 degree above the plane, it means that the incident ray would fall on this plane in this direction, and perpendicular is also in this direction. So the angle between the incident ray and the normal to the plane is 0 degree because both are in line. When the angle between these, the incident ray and the normal to the plane is 0 degree, then the cos of 0 is 1. It means we are receiving the 100% of the light when the bulb is installed just above the surface of line. But if we move the bulb to a 30 degree tilt location, then cosine of 30 degree would be 0.087. It means we are receiving the 87% of the light. And if we tilt the bulb to 60 degree, then cosine of 60 degrees 0.05. It means we are receiving only 50% of the light. Similarly, if we incline the bulb to 85 degree, then cosine of 85 is 0.09. It means we are receiving only 9% of the light. Similarly, if we move the bulb to 90 degree, then practically approximately cos of 90 degree is 0 degree. It means no light would be received on the surface of this particular plane when the light or the light source is at 90 degree to the perpendicular to the plane. This law is that the cosine law of illuminance, that the illuminance is directly proportional to the cosine of angle between the incident ray and the normal to the plane. Any question here? If you are not understanding anything, you can ask at any time, and you can ask questions in Urdu as well if you are not understanding anything. So if you are not understanding, free to ask any question.
ये जो फिगर में 30 डिग्री में शो किया हुआ है, इसका मतलब है कि इंसिडेंट लाइट जो है वो इस डिग्री पे आ रही है और हमारा नॉर्मल जो था वो वही है 90 वाला, तो उनका जो लाइट हमें जो इफेक्ट आएगा वो कम होगा पहले वाले से।
जी, मैंने वही आपको बताया कि हमारे पास परपेंडिकुलर ऑफ द प्लेन तो हमारा 90 डिग्री पर ही रहेगा। ये हमारी अगर सरफेस है जो ब्लैक लाइन की हमें नजर आ रही है, तो इसके जो परपेंडिकुलर है वो तो हमेशा 90 डिग्री का ही इसके साथ एंगल बनाएगा। परपेंडिकुलर समझे इस डायरेक्शन के अंदर है। अगर लेट्स सपोज कि मेरा बल्ब लगा हुआ है यहाँ पर, पॉइंट बल्ब, तो इट मीन्स इसकी जो लाइट रेज आ रही हैं वो परपेंडिकुलर के साथ जो एंगल बनाएंगी वो 30 डिग्री का बनाएंगी। जब वो एंगल 30 डिग्री का बनाएंगी तो कॉस ऑफ 30 डिग्री होता है, उसको कैलकुलेटर पे आप कैलकुलेट अगर करें कॉस ऑफ 30 डिग्री, तो दैट वुड बी 0.87. सो इट मीन्स दैट 13% ऑफ द लाइट वुड बी रिमूव्ड, और यू कैन से दैट जाया हो जाएगी हमारे पास 30% लाइट, जो कि इंसिडेंट रे पे नहीं पड़ेगी। सिर्फ 87% ऑफ द लाइट हमें रिसीव्ड होगी। क्यों? कि एंगल परपेंडिकुलर और इंसिडेंट रे, जो बल्ब से जो लाइट आ रही है, उसको मैं एक पॉइंट बल्ब शो कर रहा हूँ कि मेरे पास पॉइंट बल्ब है, तो उससे जो लाइट निकल रही है वो सिंपल एक रे की सूरत के अंदर निकल रही है। तो रे ऑफ लाइट जो इसके ऊपर पड़ रही है वो यहाँ पर इस डायरेक्शन के अंदर पड़ रही है एट द रेट ऑफ 30 डिग्री। एंगल 30 डिग्री किसका बना है? नॉर्मल टू द प्लेन एंड इंसिडेंट लाइन। यही मैंने डेफिनेशन के अंदर बताया, द एंगल बिटवीन द डायरेक्शन ऑफ द इंसिडेंट लाइट और इंसिडेंट रे एंड नॉर्मल टू द प्लेन। नॉर्मल टू द प्लेन तो हमेशा 90 डिग्री ही रहेगा, लेकिन ये वाला एंगल बल्ब का हम चेंज कर सकते हैं कि बल्ब को हम किधर हमने रखना है। अगर बिल्कुल मैं उसके ऊपर रखूंगा तो इंसिडेंट रे का एंगल और नॉर्मल वो 0 डिग्री बनेगा। कॉस ऑफ 0 90, कॉस ऑफ 90 जो है वो 1 होता है, तो पूरी 100% लाइट हमें रिसीव होगी। लेकिन अगर मैं बल्ब को यहाँ पर मूव कर दूं तो अब जो इंसिडेंट रे पड़ेगी इसका जो नॉर्मल के साथ एंगल का डिफरेंस होगा वो 30 डिग्री होगा, एंड कॉस ऑफ 30 डिग्री इज 0.87। इट मींस 87% ऑफ द लाइट हमें रिसीव होगी। और सिमिलरली अगर मैं बल्ब को बिल्कुल ही यहाँ 90 डिग्री पर ले जाऊं तो अब एंगल बनेगा जब इसका सरफेस के साथ यहाँ पर परपेंडिकुलर का दिस एंगल 90 डिग्री और बल्ब का एंगल इसके साथ 90 डिग्री का बनेगा। कॉस ऑफ 90 0, तो प्रैक्टिकली इसके ऊपर आपको सरफेस के ऊपर कोई लाइट जो है वो डायरेक्टली नहीं मिलेगी। क्लियर हुआ है?
यस सर, क्लियर है।
किसी और का कोई क्वेश्चन हो? क्योंकि ये दो लॉज का समझना बहुत ज़रूरी है। जब समझ ही नहीं आएंगे तो हम इसको वेरीफाई कैसे करेंगे? तो समझना बहुत ज़रूरी है। पहला लॉ हमें ये कह रहा है कि इल्यूमिनेंस, दोनों इल्यूमिनेंस से ही रिलेटेड हैं। जो लक्स को ही हम मैयर कर रहे हैं कि लाइट का जो पैमाना है, जो लाइट की रोशनी का, उसी को मैयर कर रहे हैं। पहला लॉ ये कह रहा है कि जितना डिस्टेंस बढ़ता जाएगा इल्यूमिनेंस उतनी कम होती रहेगी। लेकिन कितनी कम होती रहेगी? इनवर्स स्केयर के साथ रिलेशन है कि जितना डिस्टेंस बढ़ाएंगे उसके स्केयर के साथ जो है वो इल्यूमिनेंस हमारे पास जो है वो कम होती रहेगी। और दूसरा लॉ हमें कह रहा है कि डायरेक्टली प्रोपोर्शनल है कोसाइन ऑफ एंगल के लिए। ये एंगल इंपॉर्टेंट है। एंगल किन दो चीजों के दरमियान है? एक नॉर्मल टू द प्लेन और दूसरा है इंसिडेंट लाइट रे। यहाँ पर ये जो मैंने ब्रैकेट्स के अंदर यहाँ पर लिखा हुआ है, एंगल किन दो चीजों के दरमियान है? द एंगल इज बिटवीन द डायरेक्शन ऑफ द इंसिडेंट लाइट and the normal to the plane. First you have to draw a normal to the plane. Normal is perpendicular to the plane, and then you have to draw the incident ray light and measure the angle between normal to the plane and the incident light. Clear?
Yes, sir. Clear.
Okay, before
एक्सक्यूज मी
performing
सर.
practical, जी जी पूछिए.
सर इन दोनों जो आपने लॉज पढ़ाए हैं इन दोनों में हम फाइंड इल्यूमिनेंस ही कर रहे हैं, तो इनमें से ज्यादा एफिशिएंट वाला कौन सा लॉ है?
ये जो दूसरा फार्मूला मैंने यहाँ पर लिखा है, ये दोनों लॉस को कंबाइन करके लिखा है. यानी एक लॉ हमें बता रहा है कि जस्ट इसका रिलेशन इनवर्स रिलेशन है, इल्यूमिनेंस का इसके साथ इनवर्स रिलेशन है डिस्टेंस के साथ, और कॉस थीटा के साथ डायरेक्ट रिलेशन है. लेकिन टोटल ये इल्यूमिनेंस हमारी तीन चीजों पे डिपेंड कर रही है. एक, फर्स्ट इज द इंटेंसिटी ऑफ लाइट. यू कैन से दैट आई हैव टोल्ड यू luminous intensity that is in candela power. You can say that how much bright is light. बल्ब कितना बड़ा है, वो कितनी ल्यूमिनस इंटेंसिटी वो दे रहा है, उसके डायरेक्टली प्रोपोर्शनल है. कि सबसे पहले जारी बात है, जितना बड़ा बल्ब होगा, जितनी ज्यादा इंटेंसिटी की लाइट होगी, हमें इल्यूमिनेंस क्या है, रिसीविंग साइड के ऊपर, हमें सरफेस के ऊपर जो लाइट हमें मिल रही है वो हमें उतनी ज्यादा मिलेगी. जितना छोटा बल्ब होगा उसकी इंटेंसिटी उतनी कम होगी, उतनी ज्यादा इल्यूमिनेंस हमें कम मिलेगी. दूसरी चीज है डिस्टेंस. जितना डिस्टेंस ज्यादा होता रहेगा उसके स्क्वायर के साथ जो है वो इल्यूमिनेंस कम होती रहेगी. ये वैसे भी मुशाहिदा हमारा आम ही है कि लाइट से आप जितना दूर जाते रहेंगे तो रिसीविंग जो लाइट है आपको वो कम होती रहेगी, लेकिन कम कितनी, डायरेक्टली इनवर्सली प्रोपोर्शनल यानी स्क्वायर के साथ जो है वो इनवर्स रिलेशन है. और तीसरी चीज जो इल्यूमिनेंस जिसके साथ है वो है कोसाइन ऑफ थीटा. और थीटा किन दो चीजों के दरमियान है, इंसिडेंट रे एंड नॉर्मल टू द प्लेन. इसके भी डायरेक्टली प्रोपोर्शनल है. तो इन तीनों से चीजें जो ओवरऑल लाइट हमें मिल रही है वो इस टोटल ओवरऑल फार्मूले से है. तीनों चीजें हमारे पास हैं कि बल्ब कितना बड़ा या छोटा है, डिस्टेंस कम है या ज्यादा है, और कोसाइन ऑफ एंगल जो है वो कितना बन रहा है. तो इन तीनों चीजों के ऊपर डिपेंड करके हमें इल्यूमिनेंस मिलेगी सरफेस के ऊपर जहां पर हम काम कर रहे हैं.
ओके सर, थैंक यू.
Okay, before going to practically perform this experiment and practically prove this law, both these law that illuminance is inversely proportional to the distance between the light source and the working plane, and the second law states that illuminance is directly proportional to the cosine of angle. Before practically verifying that laws, we have to do or learn an example. Although examples are usually not part of labs, but this example is very comprehensive, and you can verify your practical results with the help of this example. This, because I would not be available to verify your practical results, that whether they are correct or not, you can verify your own results using this example. By changing just the parameters of this particular example, and you can easily solve and measure and calculate the illuminance at any point. So this example is important to verify your practically concepts, because I would not be available to verify your readings, that how much accurate are they and how much correct are they. So you can verify your practical results with the help of this example. This is a simple example. We have to use this particular formula in this example, or some basic trigonometric laws. So we learn this example first, then we would perform our practical part of this experiment. So that is the, let's read out the example. A section of a road is being illuminated by two lamps. It means a road that is illuminated by two bulbs. Lamp 1 is of 500 CP, means 500 candela power. CP is the unit of, you can say, that light that a bulb is emitting. And the other bulb or other lamp is of 400 CP, candela power, both being horizontally 20 meters apart. It means that the distance between these two lamps is 20 meters. The lamps are suspended at 6 meters above the road level. It means that the height of the bulb from the road or from the ground or from the working surface is 6 meters. This can be seen in this figure. We have two lamps. The first lamp L1 is of 500 candela power and the other lamp is of 400 candela power. Both of these lamps are above the road. The road is ACB, that is our road, and both the lamps are 6 meters above the ground level or above the road level, or you can say above the surface that we are working on. And the distance between these two bulbs is total 20 meter. That is given that the distance between two bulbs is 20 meter, and the height of these two bulbs is 6 meter, and the power of these two lamps is 500 candela power and 400 candela power. Now, what we have to calculate: illumination at point A directly below the lamp L1. We have to measure the illumination at point A directly below the bulb L1. Number 2, illumination at a point B directly below the lamp L2. We have to measure the illumination directly below the lamp at point B. Then we have to measure the illumination at a point C on the center of the line at the midway between A and B. We have to measure the light that we are receiving and the center of these two bulbs. So that is the example that we are going to measure the illumination at point A, B, and C. Solution. First, we have to tell that all 3 points A, B, and C would be illuminated by both these lamps. It means that all 3 points are receiving light from both of these two bulbs. First, we have to measure the illuminance at point A. So, point A is receiving the light from lamp 1 and also from the lamp 2. So the formula to calculate the illumination or illuminance is L1, the illuminance due to the lamp 1 is that I1 is the intensity of bulb 1 divided by H1 ka square. It means that the distance between this bulb and the working plane, the square of this distance, multiply by cos theta. Cos theta is the angle between the incident ray and the normal to the plane. So putting the formula is same that we have studied. E is equal to I divided by d square multiplied by cos theta. We are just putting the values in this formula. Now here I, intensity of the bulb is 500 CP, that is given in an example that lamp 1 is of 500 candela power. Divide by distance between the light source and the working plane and the square of that distance, and the distance between light and the working plane is 6 meter, and the square of this 6 meter is 6 multiplied by 6. Multiply by cos theta. Cos theta. Theta is the angle normal to the plane and the incident light. So normal to the plane and the incident line would be in same direction. It means the angle between normal to the plane and the incident light is 0 degree, and cos of 0 degree is 1. So putting the value of this cos theta is equal to 1. Clear है यहाँ तक?
Yes, sir.
By just putting the values 500 divided by 36 multiply 1, that is 13.89 lux. That is just not cube. That is 3. Differentiate between different types of angle. That is cos, not cube of cos theta. That is just cos theta 1. 3 is just a symbolic part to represent that theta that is different from theta 1, 2, or etc. That is just theta 1 that we have studied in this formula. That is, there is no cube or square. That is just cos theta. Clear? But we have just measured the illuminance due to the bulb or lamp L1. We have to measure the light that we are receiving from lamp 2 at point A as well. So the illumination due to lamp 2, we have measured the first measure the illumination due to lamp 1. Next, we are going to measure the illumination due to lamp 2. That would be I2. It means the intensity of light of lamp 2 divided by distance between lamp 2 and that particular point A and the square of that particular distance multiply by cos theta. Now just you have to recall some the trigonometric function. Suppose a right angle triangle is made, that is A, L2 and B. That is a right angle triangle. And AL2 is the hypotenuse of that particular right angle triangle. AB is the base of that right angle triangle, and L2B is the perpendicular of that particular right angle triangle. So the distance between A and this lamp 2 is the hypotenuse of this right angle triangle. And the formula to measure the hypotenuse is AL2 का square is equal to AB का square plus BL का square. That is the formula to measure the hypotenuse of the any right angle triangle. And just putting the and cos of theta, that is the trigonometric function. The trigonometric function cos of theta of right angle triangle is L2B, that is perpendicular divided by hypotenuse. Cos theta is the perpendicular of any right angle triangle divided by hypotenuse of that particular triangle. Have you studied the trigonometric functions? You know about, or just I am trying to recall these things? Just wait so that I can show you some. That is basically the trigonometric functions that I am going to recall you. You have well studied these things in your intermediate, but I am just recalling these concepts. That is a right angle triangle. That is basically red line is the hypotenuse of right angle triangle. Blue line is the adjacent or the base of the right angle triangle, and that is the opposite or perpendicular of the right angle triangle. So cos of theta or any degree is the base divided by hypotenuse, or you can say that adjacent divided by hypotenuse of any triangle. So we are going to use this trigonometric function in our particular lab. Any question here? Okay, let's get back to our topic. So here, cos of theta would be L2B. L2B is the perpendicular of right angle triangle divided by AL2. AL2 is the hypotenuse of that particular right angle triangle. Again, ask the question.
जो L2B है वो बेस है हमारे पास.
That is the right angle triangle L2B. That is the right angle triangle. That is hypotenuse. Or you can say that a base of this particular triangle, or you can adjacent. You can you can consider this right angle triangle as this one. So cos of theta would be hypotenuse divided by AL2. AL2, this is the hypotenuse. L2B. L2B base, or you can say that base divided by hypotenuse. Cos theta is equal to L2B divided by AL2. L2B is this, and L2A is hypotenuse. So that is the trigonometric function. And L2B, what is the L2B? The value of L2B is 6 meter, because lamps are 6 meter above the road level. Okay. And similarly, AL2 is the hypotenuse, and to measure the hypotenuse we have p का स्क्वायर प्लस BL2 का स्क्वायर होल अंडर रूट, दैट इज 6 का स्क्वायर plus 20 का square whole under root. In this way, we can get the hypotenuse. So that is 6 divided by 20.88. That is cos theta is 0.287. Any question here?
सर यहाँ पे बेस ए भी नहीं होगा?
आप राइट एंगल ट्राइंगल को दो तरीके से देख सकते हैं। एक तो इस तरह से देख सकते हैं कि ये हमारे पास बेस इसकी ये है, या तो ए बी है, या फिर हमारे पास जो है वो BL2 है। अगर आप इसको दूसरी तरह खड़ा करके देखेंगे, इधर से भी राइट एंगल ट्राइंगल आपके पास जो है वो बन रही है, ये भी राइट एंगल ट्राइंगल। इसको आप अगर आप थोड़ा सा ना लैपटॉप को 90 डिग्री घुमा दें, आप अपने 90 डिग्री आप इसको जो है वो राइट की तरफ टिल्ट कर दें, तो फिर आपको जो है वो राइट एंगल ट्राइंगल जो है वो नजर आएगी। तो उसमें फिर आप जो है वो फार्मूला उसका जो है वो आप देख लें कि उसके मुताबिक की जो मैंने आपको फिगर दिखाई थी उसके अंदर थोड़ा सा चेंज था, लेकिन जस्ट यही है कि इसकी बेस और हाइपोटेन्यूज का जो है ना वो है कि वो अगर आप इसको 90 डिग्री टिल्ट करेंगे तो ये आपके पास बेस और हाइपोटेन्यूज आपके पास जो है वो आ जाएगा। Then we have D. D is AL2. AL2, that is the hypotenuse, and that is measured by this 6 square plus 20 square whole under root, that is 20.88 meter. So we have now measured the distance between A and lamp 2, that is the hypotenuse, is 20.88, and the theta that is making at this degree is 0.287. By just putting the value in the formula that we have studied earlier, in this formula we have now we have luminous intensity 400 cp, that is the intensity light of bulb number 2, and d square is the distance between lamp 2 and at point 1, that is the hypotenuse of right angle triangle that we have also calculated, and the cos theta we have calculated that as well. So by just putting the values 400 divided by 20.88 square multiplied 2.287, we have total illumination due to lamp 2 at point A is 0.263. So total illumination at point A would be the illumination due to the lamp L1, that is 13.89, and the illumination due to L2 is 0.263. So the total illumination at point A is 14.153 lux. In this way, you have calculated the total illumination at this particular point at A. Normally, we have to perform experiment for a single bulb or a single light source. That would be quite easy to use this formula and practically rectify or correct these results. But I have taken an example of two light source so that you can learn better. Although our experiment would be depend upon a single light source, but for learning purpose, I have taken the two bulbs. But if we have a single light source, then our example would be finished at this point. Only 3 steps: putting the value of intensity of bulb, distance between the light, and cosine of angle. We can get the light easily. Any question here?
सर इसी तरह से बी और सी पर भी निकाल सकते हैं हम?
बिल्कुल वही मैंने अभी सेकंड पार्ट भी है, इल्यूमिनेशन एट अ पॉइंट बी। ये मैं जल्दी बताऊंगा आपको थोड़ा सा क्विकली। illumination at a point B directly below the L2, that is the second part of our example. We have to measure the illumination at point B, just below the lamp 2. So the light illumination, the point B is illuminated by this lamp and this lamp also. So the next part is the illumination due to lamp L2 by using the same formula that we have studied earlier. The formula would be same: I divided by d square multiplied by cos theta. I is the intensity of luminous intensity of light, that is 400 cp candela power, divided by distance between the lamp and the point is 6 meter. Distance between the lamp 2 and the point B is 6 meter. So the square of that particular distance, and cos theta 2. Now cos of 0 is 1, so we have to multiply this with 1. 400 divided by 36 is equal to 11.11 लक्स इज इक्वल टू का साइन मिसिंग है यहाँ पर, इसको आप देख लीजिएगा कि फॉर जस्ट 400 डिवाइड बाय 36 मल्टीप्लाई बाय 1 बिकॉज the incident ray and normal to the plane is making an angle 0 with the incident ray. So we have cos of 0 is equal to 1. Clear way? Clear hai? Any question here?
Yes, sir.
But the point P is also illuminated by the lamp 1. So we are going to measure the illumination due to the lamp L1 by using the same formula. I divided by distance between point B and L1, that is L1B. L1B ka square multiplied by cos theta. Now cos theta is again using the same trigonometric functions. L1A divided by L1B, 6 divided by 6 square plus 20 square under root is equal to 0.87. That is the value of cos theta. And similarly, the hypotenuse would be same as that of that length, but you can again calculate that particular hypotenuse using that right angle triangle, that is L1A and B. Using that right angle triangle, you can measure the hypotenuse this by just putting the values in this formula. 500 in this value, intensity of lamp 1 is 500, multiply cos theta is 0.287, and the divide by the distance between point B and lamp L1 is 20.88. So 20.88 square root of 20.88. By just putting the values, we get the value of 0.329 lux, and the total illumination at point B is illumination due to lamp L2, that is 11.11, and illumination due to lamp 1 is 0.329. So the total illumination at point B is 11.44 lux. That is same as that we have done in part 1, that illumination of point at 1. Now the third part is illumination at point C, that is on the center line at the midway between point A and B. We have to measure the light at point C. Point C is also getting the light from the lamp L1 and also getting the light from the L2. Now there are two right angle triangles. One is ACL1 and the other is BCL2. Now there are two right angle triangles. Now the third point, the light we are getting due to lamp 1 using the same formula. Intensity of the lamp L1 is 500 candela power, and L1C. Now we have to measure this particular hypotenuse. Now this hypotenuse would be 6 square plus 10 square, not 20 square, because previously in both previous two parts we have perpendicular of 20 meter, but here we have a perpendicular of 10 meter only. That is a right angle triangle. So 6 square plus 10 square, not 20 square. So we are 6 square plus 10 square whole under root. We are getting 136. That is square root of 136. That is 11.662 meter. Clear? Similarly, yes, again, cos theta would be 6 divided by that hypotenuse, that is 11 point something. So the cos theta would be 0.5145. Putting the value in this particular formula, 500 is the intensity of lamp 1 divided by the distance between L1 and the point that we are measuring light, that is 11.662 meter apart. The point we are measuring on light is C, and the lamp is 11.662 meter apart. So the distance between lamp and this point is 11.662 meters. Square root of this multiplied by cos theta. Cos theta we have calculated earlier, 0.5145. So putting these values, we have 1.9 lux due to lamp 1. Now the illumination due to lamp 2 would be same by using the formula. 400 is the intensity of lamp. Cos theta would be same, 0.514 divided by the distance between lamp 2 and point C. is same 136 because L1C would be same as that of L2C. So the distance between L2 and C would be same as L1 and C point. So by just putting the value, we have 1.52 lux. So the total illumination at point C would be illumination due to lamp 1, that is 1.9, and the illumination due to lamp 2 is 1.52. So the total illumination we are receiving at point C is 3.42 lux. Any question here? This example is very comprehensive, and you can measure the light at any point having two light sources as well and one light sources as well. You can easily measure the light at any surface using these formulas and using these concepts. Any question here? Now I would come towards the practical performance of this lab. To perform this particular lab, the apparatus required would be measuring tape or any meter rod or at least a scale or a ruler. Next is the light source or a bulb, any LED light or a bulb, but not tube light. Your light source should be a point light source to perform or verify this experiment. Keep this thing in mind. Do not perform this experiment under a tube light or a light which is distributed. Use a light source that is of point type, like energy saver or LED bulb or a simple incandescent bulb or anything like that, but do not use tube light for this particular purpose. Lux meter, I have already told you, Lux meter is a device to use to measure the total light in lux or in lumens. We have calculated the lux in this example, but you can practically measure the lux at any surface or any point using the Lux Meter. Although you do not have Lux Meter in your home, but your smartphone can be converted into a Lux Meter by just installing a simple app called Light Meter or a Lux Meter. And finally, you have to measure the angle between the bulb and the working surface. You have to need a angle measuring instrument or protector, which you called as a D. And you can measure the angle using your smartphone as well, because there are a lot of apps to measure the angle by using the gyroscope of your mobile. So you can install an app if you do not have a protector already as well. You can use your smartphone to measure the angle. So these are the four things that are required to perform our experiment. Any question here? Let's move toward the procedure. The procedure to perform this experiment is very simple, but the verification of this is a complex task. The first step is you have to verify both these two laws separately. First, you have to verify the inverse square law. Then you have to verify the Lambert cosine law. When you are verifying the inverse square law, you have to keep the angle same. You cannot change the angle when you are performing or verifying the inverse square law. Similarly, when you are performing the Lambert cosine law, you cannot change the distance between light source and your working plane. So these two laws, you have to verify these two laws separately, not combined. You have to keep other thing constant while performing any experiment, while verifying any law. So the first three steps are used to verify the inverse square law. First, you have to measure distance between working plane and the lamp. Lamp is any light source, a single light source that can be a LED light or energy saver or incandescent lamp or anything like that. And your working plane can be a table on which you are reading a book or doing some work, or can be your floor if you are doing some work on your floor. So working plane is the plane on which you are doing work, or in this experiment, working plane is the plane where you have to put your mobile phones to measure the light in lux. Okay, so first you have to measure the distance between your bulb, your light, and your working plane. Then step number 2, measure illumination at working plane by using a lux meter or your smartphones. Then write the readings at that particular table. Observation and calculation, we have a table. First you have to fill this table of distance between lamp and working plane. Suppose your first reading would be at 0.5 meter from the bulb. Your working plane would be 0.5 meter from the light source or from the bulb. You have to measure the illumination or light or lux with the help of lux meter and write the value here. At 0.5 meter, you are receiving this particular type of light. Maybe you can say that you are receiving 100 lux. Now you have to increase the distance to 1 meter. You have double the distance. When you have doubled the distance from 0.5 meter to 1 meter, your illumination in lux would decrease 4 times. That is what inverse square law says. You have to verify that your illumination, if you increase the distance to double from 0.5 meter to 1 meter, your illumination would be reduced to from 100 lux to just 25 lux. Similarly, you have to increase the distance from 1 meter to 1.5 meter and again measure the illumination at that particular point and write the reading. Then you have to increase the distance to 2 meter and final value would be at 2.5 meter. So you have 5 different distance and 5 values of illumination for the verification of inverse square law. Then you have to verify your concept or the law that by increasing the distance, whether your illumination would be decreasing by the square of function or not. You have to verify these things. Or another thing, you can calculate by using the concept that you have learned in this particular example, that here is the light source, that is your working plane, single light bulb, single light source, just the distance. You have to just write these values in this formula to calculate the lux. Now change distance between source and the working plane and measure illumination to verify inverse square law. Just I have told you earlier that first reading would be at 0.5 meter, then 1 meter, then 1.5 meter, then 2 meter, then 2.5 meter. You have to write down the 5 readings and against 5 reading you have to write 5 values of illumination or lux against these 5 values. Any question here? Distance can be measured with the help of measuring tape and illumination can be measured with the help of your smartphone mobiles using the app Lux Meter or a light meter. The next part is the verification of Lambert cosine law. One thing I have missed, that while performing or verifying the inverse square law, you have to keep the cos of theta constant. You cannot change the angle while verifying the inverse square law. Okay. Next, while verifying the Lambert cosine law, you have to keep the distance between lamp, bulb and the working space constant. You cannot change the distance while verifying the Lambert cosine law. So first you have to measure the reading, keep constant distance of, you can say that, which is visible to you, like 1 meter or 1.5 meter or 2 meter, any value from the light source, and measure the angle between the light source and normal to the plane that you are working on. Plane or normal to the plane is perpendicular to the surface that you are working on. Suppose you are working on a table, or then draw perpendicular, that would be perpendicular to your table, and measure the angle between the incident ray and that particular normal to the plane. First you have to keep your working plane just below the bulb, making that angle 0. It means the angle of incident ray and normal to the plane would be 0 for first reading. Then you have to change the reading to 30 degree. then 45 degree, then 60 degree, and finally 90 degree. You have to write down the values of lux against that value. Now here, while performing the second part of this experiment, your working plane is your mobile, your smartphones, on which you are measuring the lux using light meter or a lux meter. You have to tilt your mobile to 30 degree, 45 degree, 65 degree, and 90 degree to the light source or to the bulb. Any question here?
सर इसमें जब हम लोग फर्स्ट में टास्क कर रहे थे तो हमने डिस्टेंस का चेंज किया था 5 पॉइंट।
जी जी,
तो उसके बाद जब आपने कहा कि डिस्टेंस को कांस्टेंट रखना है तो हम लोग कौन सा वाला डिस्टेंस कांस्टेंट रखेंगे? कोई भी एक ले लेंगे?
जी कोई भी एक रख लेंगे, वो जो आपको फिजिबल लगे, जो लाइट सोर्स है। मैं ये कह दूं जी 1 मीटर बल्ब आपका छत पे लगा हुआ है, तो 1 मीटर भी हाइट उसकी काफी ज्यादा है, तो 1 मीटर आप नहीं कर सकते, पॉसिबल नहीं है आपके लिए। या तो आप कोई भी 2 मीटर का फासला रख लें जो आपको फिजिबल हो, 1.5 मीटर का रख लें, 1 मीटर का रख लें, 2.5 मीटर का, जो फिजिबल हो आपके लिए। लेकिन पांचों रीडिंग के लिए वो डिस्टेंस आपका कॉन्स्टेंट होना चाहिए, क्योंकि अगर डिस्टेंस चेंज हो रहा होगा तो वेरिफिकेशन ला की इसके एंगल के साथ नहीं होगी। ये जो मैंने अभी ये चीज कंसेप्ट आपको पढ़ाया है ना कि ये रीडिंग्स आपने लेनी है, ये डिस्टेंस को कांस्टेंट आपने जो है वो रखना है, यानी कि जो वर्किंग प्लेन, जो मोबाइल है आपका, वो वर्किंग प्लेन हो जाएगा। उसका बल्ब के साथ जो डिस्टेंस है वो, या डिस्प्लेसमेंट आप कह लें, वो उसकी जो है वो कांस्टेंट होनी चाहिए आपकी तमाम केस के अंदर। क्योंकि अगर डिस्टेंस भी साथ में चेंज करते रहेंगे तो ये लॉ वेरीफाई नहीं हो सकता। आपको जो है वो डिस्टेंस को कांस्टेंट रखना है, सिर्फ एंगल को चेंज करना है। पहले आपने जस्ट मोबाइल को रखना है। अब इस केस के अंदर आप लाइट सोर्स को तो चेंज नहीं कर सकते, क्योंकि नॉर्मली आपका बल्ब जो है वो दीवार के साथ या छत के साथ फिक्स होगा। तो आपने क्या करना है, इन दोनों के दरमियान एंगल को चेंज करने के लिए आप अपने मोबाइल फोन्स को जो है वो, जो स्मार्टफोन्स को जो है वो, उसकी पोजीशन को आप चेंज करेंगे। सबसे पहले लेट्स सपोज कि ये बल्ब है आपका, ठीक है, जो 0 डिग्री जहाँ पे लिखा हुआ है यहाँ पर बल्ब लगा हुआ है, तो सबसे पहले आपने ये रखना है कि डिस्टेंस आपका ये लेट्स सपोज कि 2 मीटर हो गया। देन 2 मीटर रखते हुए आपने जो है वो बिल्कुल उसके नीचे रखना है, तो कि आपका नॉर्मल टू द प्लेन यानी नॉर्मल टू द मोबाइल फोन एंड द इंसिडेंट रे 0 डिग्री का एंगल बने। तो मैक्सिमम लाइट आपको इस पॉइंट के ऊपर मिलेगी जब आप बल्ब के जस्ट नीचे रखेंगे सरफेस को, ठीक है। फिर आपने क्या करना है कि थोड़ा सा जो है वो मोबाइल फोन को 30 डिग्री का एंगल थोड़ा सा आपने इधर मूव करना है, लेकिन एट द सेम टाइम आपको उसको थोड़ा सा जब इधर मूव करेंगे तो आपको थोड़ा सा मोबाइल को ऊपर उठाना पड़ेगा ताकि डिस्टेंस उसका जो है वो 2 मीटर मेंटेन रहे। जो इधर आपने 2 मीटर रखा था वो इधर भी 2 मीटर मेंटेन रहे। अब एंगल जब 30 डिग्री बनेगा आपका, तो फिर आपके जो है वो लक्स जो है वो कम हो जाएंगे। कितना कम होंगे? 13% कम हो जाएंगे। देन फिर आप एंगल को थोड़ा 45 डिग्री करेंगे, 60 डिग्री करेंगे। जब मोबाइल को आप इधर रखेंगे बिल्कुल सीधा करके बल्ब के बिल्कुल 90 डिग्री के साथ, जब आपका नॉर्मल टू द प्लेन आपका ये बनेगा और इंसिडेंट रे आपका जो है वो ये बनेगा, नॉर्मल टू द प्लेन आपका ये बनेगा और ये 90 डिग्री जब होगा तो अप्रोक्सीमेटली आपको जो है वो 0 लक्स जो है वो, या 0 लाइट जो है वो यहाँ पर उसको जो है वो आपको मिलेगी। क्लियर हुआ?
यस सर।
और जब पहला केस आप कर रहे हैं, यानी कि आप वेरीफाई कर रहे हैं इन्वर्स स्केयर लॉ, तब आपने एंगल जो है वो आपने कांस्टेंट रखना है, यानी कि 0 डिग्री रखें तो ज़्यादा बेहतर है बनिस्बत इसके कि 30 डिग्री रखें या 45 रखें। पहले केस के अंदर आप 0 डिग्री रखें ताकि जस्ट बिलो दा, और जस्ट डिस्टेंस को चेंज करें। डिस्टेंस को चेंज करने से इन्वर्स स्केयर के साथ जो है उसका इन्वर्स रिलेशन जो है वो साबित होना चाहिए। ये आपका जो है दो पार्ट्स।
जब हम फॉर्मूला देखें उसमें तो कोस थीटा वगैरह तो इन्वॉल्व होता ही नहीं है, तो फिर उसको हम क्यों करें कंसीडर?
किसका फार्मूला?
फर्स्ट वाला जो हमने किया था,
ये वाला इन्वर्स स्केयर लॉ है। एक्चुअली दैट इज नॉट बेसिकली इज इक्वल टू, दैट इज डायरेक्टली प्रोपोर्शनल का साइन है यहाँ पर। तो ये दोनों चीजें मिलकर ही जो है वो पूरा इल्यूमिनेशन तो 3 चीजों पे टोटली डिपेंड कर रही है कि इंटेंसिटी ऑफ लाइट, एक्चुअल फार्मूला ये बनता है। हमने इन दोनों को अलग-अलग वेरीफाई करना है, डिस्टेंस को भी और कॉस थीटा को भी। ये इल्यूमिनेशन का फाइनल फार्मूला है जो हमने एग्जांपल के अंदर भी यूज किया, और आप इसकी जो है वो जब थ्योरेटिकली वेरिफिकेशन करेंगे तो यही वाला फार्मूला आपने इस्तेमाल करना है। इसके अंदर डिस्टेंस जो है वो डिस्टेंस के ऊपर भी डिपेंड कर रही है इल्यूमिनेशन, और कॉस थीटा के ऊपर भी। तो दोनों को अलग-अलग वेरीफाई करना है, तो एट द सेम टाइम हमें एक चीज को कांस्टेंट रखना पड़ेगा, दो चीजों को हम एट द सेम टाइम वेरीफाई नहीं कर सकते हैं। हमें दोनों चीजों को अलग-अलग जो है वो, एक चीज को कांस्टेंट रखेंगे तो दूसरी चीज वेरीफाई हम कर सकते हैं, फिर दूसरी चीज को कांस्टेंट रखेंगे तो पहली चीज हम वेरीफाई कर सकते हैं। तो ये हमारे पास इल्यूमिनेशन का अलग फार्मूला है, यानी कि ये दोनों चीजें साथ ही साथ हैं, यानी कि एक को हम निकाल नहीं सकते हैं इसमें से।
ठीक है सर।
Any other question? Okay, now there are some precautions and the precaution is you have to use a single light source for performing this experiment. If there are multiple light sources in a room, then it is not possible to verify the inverse square law using the same concept, because if there are two lamps in your room, then each point on your room is receiving light from two light sources. So you have to perform very complex calculation like this. So you have to perform this experiment using a single light source. Okay, first thing. Next thing, you have to use a point light source. You cannot use tube light, etc., or a distributed light source for performing this experiment. Third thing is make sure that while performing this experiment, the room you are performing this experiment doesn't receive sunlight from windows or from doors, because if sunlight is entering from door or windows, then that might affect your readings. So try to perform this experiment at night, or keep your windows and doors closed so that no sunlight is entering in your room, because that light would increase the chances of your error. And your results might not be 100% accurate by theoretical value and your calculated value and your practical values. Your calculated value using these formula and concepts and your practical value that you are going to observe by performing this experiment might differ a little bit due to some things that we have neglected in this particular lab. Basically, there are some other factors like utilization factor or a depreciation factor or diffused light or reflected light and some other factors. Because I taught you with some example that I have told you that when I measure the light at 90°, the law say that you would receive 0% light when you put your surface at 90° to the light source. The law say that at 90° you would receive zero light, but you may receive some light that might be 1% or 2% of the light due to diffused light, you can say that, or you can say that reflected light, the light that is reflected from the white surface of your walls, of your ceiling, of the stray lights from the sunlight or other light sources that is coming. So there might be a possibility that at 90° you are getting some light, like 1% or 2% or 3% of the light, because that is the error, that is the difference between your theoretical part and your observed part. So there is a possibility of a little bit deviation from your calculated light that you have calculated using this formula or by using the concepts that you used in this example. And there are some other factors like when your room has dust particles in the air, then some light is diffused or lost in these dust particles if your environment is not clean. Similarly, there is a utilization factor that if your the paint of your walls is white, then they reflect a lot of light. And similarly, if your walls have having wall panels of dark color, or some wallpaper on your walls having dark colors, then it would not reflect much light. So there might be a possibility that your calculated results and your observed results might differ by a small value, but you should know the reason behind these difference, and that there are some other factors that we have neglected in this particular lab. Although we would cover these factors in upcoming lab, we have another lab related to the illumination. We have total 2 labs that are related to the illumination scheme. So while performing our other lab related to the illumination, we try to cover these terms as well. But till now, there might be a small difference between your observed value and your calculated value. Any question here? You have to write a conclusion yourself. All other headings are already described in this particular lab, and I have uploaded this experiment on Microsoft Teams as well. So you can download this experiment while making your practical notebook. After performing this experiment, you have to draw this table on your practical notebooks and write the at least 5 readings to verify the inverse square law, and then you have to verify the Lambert cosine law. Then you have to write the conclusion. Conclusion is the heading that you have to write in each and every lab, that what you have concluded in this particular lab. All the headings would be described by me, whether it is procedure or theoretical background or apparatus or objectives. All headings would be told by me, but you have to write one heading, that is the conclusion, that what you have concluded by this lab. So you have to write in your own words that what you have learned, that is basically the lesson. You can say that lesson learned or conclusion or student comments as well. So you have to write at the end of this lab that what you have concluded, what you have learned by this lab. So this is the mandatory part, and this is an important heading that I must read while checking your practical notebooks. Our third experiment would most likely be on campus. So we would perform other experiments in lab. Any question till now? जी
सर, ये जो एग्जांपल आपने करवाई है, ये तो कॉपी में लिखने की जरूरत नहीं है ना?
बिल्कुल भी नहीं है। ये तो पार्ट मैंने जस्ट बताया कि ये तो पहले थी भी नहीं, ज़रूरी भी नहीं थी। अगर हम ऑन कैंपस अगर ये एक्सपेरिमेंट करते तो मैं आपकी रीडिंग्स चेक कर लेता, तो इसकी ज़रूरत ही नहीं थी। ये जस्ट मैंने कहा है कि आप अपने रिजल्ट्स को, अगर मैं चूंकि अवेलेबल नहीं होऊंगा रिजल्ट चेक करने के लिए, आपकी रीडिंग्स चेक करने के लिए कि वो एक्यूरेट है, सही या नहीं है, इस वजह से एग्जाम्पल मैंने आपको करवा दी है। इसकी कतन कोई ज़रूरत नहीं कॉपी पे लिखने की कि आप इसको कॉपी पे लिखें। जस्ट ये आपने जो ये टेबल आपने बनाना है, इसको 2 तरीकों से वेरीफाई करना है। एक तो जस्ट है इन्वर्स स्क्वायर लास्ट स्क्वायर के साथ बन रहा है या नहीं बन रहा है, और कोसाइन के साथ डायरेक्ट रिलेशन है या नहीं है। दूसरी उसकी एक्यूरेट वैल्यू किस तरह आएगी, वो आप जस्ट इन फार्मूलों को यूज करते हुए जो है वो आप कर सकते हैं। इस वजह से एग्जाम्पल मैंने आपको कराई है, ताकि ये जो ऑब्जर्वेशन एंड कैलकुलेशन है इसकी आप वेरिफिकेशन कर सकें। जस्ट इसका ये पर्पज है, वरना लैब के अंदर एग्जाम्पल्स का या न्यूमेरिकल्स की कोई तुक नहीं बनती है। लेकिन जस्ट ये एग्जांपल आपको इसलिए करवाई है ताकि आप इसको ऑब्जर्वेशन एंड कैलकुलेशंस को खुद वेरीफाई कर सकें, क्योंकि मैं चेक नहीं कर सकता। आपने जो भी वैल्यूज़ की हैं वो जब आप कॉपी पे लिख के ले आएंगे तो फिर ही मैं चेक करूंगा, और फिर जाहिर बात है जो है वो उसके होंगे। क्लास के अंदर परफॉर्मेंस करते टाइम मैं चेक नहीं कर सकता आपका, तो इस वजह से एग्जाम्पल कराई है ताकि अपने रिजल्ट को आप खुद वेरीफाई कर सकें। जी, एनी अदर क्वेश्चन?
सर, इसमें जो प्रैक्टिकली हम इंटेंसिटी किस तरह फाइंड कर सकते हैं बल्ब की?
अच्छा, नॉर्मली ये बल्ब की जो आपकी इंटेंसिटी है, ये 2 तरीकों से जो है वो आप फाइंड आउट कर सकते हैं। एक तो ये है कि जो बल्ब है उसके ऊपर जो आपके पास उसका कवर है या उसका जो डब्बा है, उसके ऊपर उसके ल्यूमेंस लिखे होते हैं। हर बल्ब के ऊपर जो नॉर्मली आजकल एलईडी बल्ब चल रहे हैं या इवन के एनर्जी सेवर भी, उसके ऊपर उसके ल्यूमेंस लिखे होते हैं कि टोटल ल्यूमेंस ही आपको कितने देगा, तो वो आप उसके जो है वो चेक कर सकते हैं। नहीं तो दूसरी बात ये है कि अगर आप जो है वो बल्ब के बिल्कुल साथ जो है वो लगा दें अपने लक्स मीटर को, तो वो उसके टोटल वो बता देगा कि उस टाइम के ऊपर उसके कितने जो है वो रेडिएट कितने कर रहे हैं या कितनी चीज़ें आपके आ रही हैं। तो इन 2 तरीकों से आप उसकी जो है वो टोटल कैंडेला पावर या ल्यूमेंस उसके जो है वो मालूम कर सकते हैं। हर बल्ब के ऊपर उसका जो डब्बा है, नहीं तो अगर आप उसकी जो वेबसाइट के ऊपर चले जाएँ जो कंपनी का, उसके जस्ट वॉट डालें तो आपको ल्यूमेंस आपके बता देता है। नॉर्मली जो यहाँ पर पाकिस्तान के अंदर जो मार्केट्स के अंदर अवेलेबल है, ये 100 ल्यूमेंस पर वाट के हिसाब से जो है ना वो अवेलेबल है। यानी कि अगर आपका 13 वाट का बल्ब है तो वो तकरीबन 1300 ल्यूमेंस आपको दे रहा है, और अगर 12 वाट का तो 1200 ल्यूमेंस दे रहा है। अगर 5 वाट का है तो 500 ल्यूमेंस दे रहा है, अगर वाट का है तो 800 ल्यूमेंस दे रहा है। तो इस तरीके से भी आप अप्रॉक्सीमेटली कैलकुलेट कर सकते हैं, क्योंकि नॉर्मली इसकी जो रेंज होती है, एफिशिएंसी ऑफ एलईडी बल्ब्स आर नॉर्मली 80 ल्यूमेंस पर वॉट टू 120 ल्यूमेंस पर वॉट। तो जो बहुत ही घटिया क्वालिटी का बल्ब होगा वो 80 ल्यूमेंस पर वॉट दे रहा होगा, जो बहुत अच्छी क्वालिटी का होगा वो 120 ल्यूमेंस पर वॉट दे रहा होगा। नॉर्मली जो बल्ब यहाँ पर मैंने लिए हैं फिलिप्स के या अल्बराका के या फिनिक्स के वगैरह के, जो अच्छी क्वालिटी के थोड़े बल्ब होते हैं जिनके वो तकरीबन 100 ल्यूमेंस पर वॉट होते हैं, तो वॉटेज के हिसाब से भी आप ल्यूमेंस को अप्रॉक्सीमेटली कैलकुलेट कर सकते हैं। और कोई सवाल हो? एनी अदर क्वेश्चन?
नो सर।
Okay, I have uploaded this lab, and this is these are some extras. Basic difference between luminance and illuminance. We have to measure the illuminance that we are getting on a surface. Luminous flux or luminous intensity is the light that is emitting from a bulb, and illuminance is the light that we are getting on a surface and illuminance is the illuminance per unit area, that how much light we are getting in this part area. That is the figure that I liked very much from the internet, so I have just pasted here this figure, because that is the basic difference between luminance and illuminance. Similarly, that is the light meter. That is I have already installed in my mobile phones. You can easily install the light meter or a Lux Meter on your mobile phones using the App Store, Google App Store. And with the help of this light meter, you can measure intensity of that lux. Any other question? So let's conclude our lab. Before closing the lab, I would take your attendance. जी जी
सर, जो हम वैल्यूज टेबल में लिखेंगे उनको वेरीफाई भी करना है सर?
जी, वेरीफाई करनी है ना आपने वैल्यूज। वेरीफाई करने के दो तरीके मैंने आपको बताए हैं। एक तो मिनिमम जो क्राइटेरिया का है आपका वो ये है कि जस्ट जैसे ही आप डिस्टेंस बढ़ाएंगे तो इल्यूमिनेशन, डिस्टेंस को डबल करने से इल्यूमिनेशन आपकी 1/4 होनी चाहिए। इल्यूमिनेशन डिस्टेंस को 3 टाइम इंक्रीज करने से आपकी इल्यूमिनेशन 1/9 टाइम्स हो जानी चाहिए लक्स आपके। तो इस तरीके से, और डिस्टेंस जब 5 टाइम्स बढ़ा देंगे तो इल्यूमिनेशन आपकी 25 टाइम्स कम हो जानी चाहिए। एक तो ये जनरल हो गया आपके पास अप्रॉक्सीमेटली। दूसरा, आप कैलकुलेटेड वैल्यू से भी यहाँ से जो फार्मूला आपका है, जिस तरह पहला पार्ट करवाया था, सिर्फ ये 3 इस फार्मूले के अंदर वैल्यूज डालेंगे। इधर इंटेंसिटी ऑफ द बल्ब, इधर आप उसकी जो है वो हाइट डालेंगे, और इधर जो है वो एंगल उसका जो है वो 1 ही रखेंगे, बिल्कुल आपने नीचे रखना है। तो उससे आप जो है वो उसके लक्स को कैलकुलेट कर सकते हैं। लेकिन ये इंटेंसिटी आपको देखनी पड़ेगी कि आपके बल्ब की जो है वो कितनी है, क्योंकि नॉर्मली जब डब्बे पे तो वो लिखी होती है, वो वैल्यू होती है जब नया आप लगाते हैं। अगर उसको आप 6 महीने हो गए यूज़ करते हुए या साल हो गया, तो उसकी नॉर्मली वो इंटेंसिटी नहीं रहती है, वो फेड आउट होना शुरू हो जाता है वक्त के साथ साथ। और 1 साल पुराना हो गया तो उसकी तकरीबन 60% या 70% लाइट जो है वो सिर्फ रह जाती है। तो इसमें आपको थोड़ी सी प्रॉब्लम हो सकती है कि इंटेंसिटी आप इस फार्मूले में जो आप जो है वो कैसे डालेंगे। लेकिन थोड़ी सी वैल्यूज डालकर आप उसको चेक करेंगे तो वो आपके पास अप्रॉक्सीमेट वैल्यूज की आ जाएगी। तो थोड़ा सा डिफरेंस मैंने कहा कि एक्सेप्टेबल हो सकता है, एरर आपका आ सकता है, लेकिन इतना ज़्यादा नहीं होना चाहिए कि आपकी ये चीज़ ही वेरीफाई ना हो रही हो। एग्जैक्ट वैल्यू हो सकता है, लेकिन ये तो वेरीफाई हो जाएगा ना कि जो डिस्टेंस को डबल करने से आपकी इल्यूमिनेशन 1/4 हो रही है, डिस्टेंस को 3 गुना बढ़ाने से आपकी इल्यूमिनेशन 1/9 टाइम्स कम हो रही है। सिमिलरली कॉज ऑफ थीटा के जरिए आप उसको देखें कि जब 0 डिग्री है तो मैक्सिमम मिल रही है, जब 90 डिग्री है तो मिनिमम मिल रही है, और इनके दरमियान वही जो एंगल का रिलेशन है कॉज ऑफ थीटा का, उसके मुताबिक आपको वैल्यूज मिल रही है या नहीं। तो वेरिफिकेशन इज इंपॉर्टेंट, वेरिफिकेशन ही तो करनी है। टाइटल को भी आप पढ़ें तो टाइटल के अंदर वेरिफिकेशन है। इन्वर्स स्केयर लॉ हमने पढ़ लिया है, लैम्बर्ट कोसाइन लॉ हमने पढ़ लिया, इसके फार्मूले भी पढ़ लिए। असल चीज तो लैब को वेरीफाई करना है, इन लॉस को प्रैक्टिकली परफॉर्म करके वेरिफिकेशन है इनकी। तो वेरिफिकेशन खाली रीडिंग करके एक तो बेसिक कंसेप्ट्स हो जाएंगे, दूसरी तो वेरिफिकेशन भी इसकी जो है वो इंपॉर्टेंट है, क्योंकि टाइटल के अंदर ही है, लैब का मकसद ही यही है कि हमने वेरीफाई करना है। ऑब्जेक्टिव में भी पढ़ें टू स्टडी एंड वेरीफाई। ये तो बेसिक लॉज हैं एलिमिनेशन के, इन्वर्स स्केयर लॉ और लैम्बर्ट कोसाइन लॉ, इनकी वेरिफिकेशन जो है वो बहुत इंपॉर्टेंट है। तो वेरिफिकेशन जरूर करनी है। और कोई सवाल हो?
सर थैंक यू।
अच्छा, अटेंडेंस आपकी जो है वो मैं ले लेता हूँ। ओके टेंडस आपकी होगी, लेट्स फिनिश दिस लैब। ओके, अल्लाह हाफिज।
सर